We talked a little bit about differentiating exponentials the other day. Let's look at it in a bit more detail then, because obviously with all our functions, eventually we want to know how to differentiate them so we can use them for rates of change questions and things like that. We talked about just e to the power of x the other day, but I mean, of course, the power could be anything. So I've just labelled the power function x. So how do we differentiate it? Well, I'm going to do it implicitly to prove the eventual formula. Well, we don't do it implicitly every single time, but this is just to prove the formula. So if I just let u equal the function of x, so now I have y equals e to the power of u. Now, if I want to differentiate with respect to x, I have to do it implicitly now, because I can't differentiate e to the power of u with respect to x, but I can differentiate it with respect to u. And then I'll multiply it by du dx. Now, we saw the other day that the derivative of just e to the x with respect to x was e to the x. So logically, derivative of e to the u with respect to u is e to the u. It's just a different pronumeral. And then we're going to multiply that by du dx. Well, du dx would just be the derivative of function x. And so there's our formula. It's quite neat. See, all we have to do is differentiate whatever the power is, and that becomes the coefficient of the exponential function. So we don't have to go through that implicit differentiation every single time. So simply, if we see e to the power of function x, I want to differentiate it, then it'll be the derivative of that power times e to the function x. Now, the one thing to be careful about, it's not a polynomial. The mistake that often happens is people subtract one from the power, because that's what we do with polynomials. The power stays the same with this. So with the exponential function, the power stays the same. So that's if the base is that Euler's number, e. If it's some other base, what do we do? Well, it turns out it's pretty much the same, but we also multiply it by the log of a. Now, that's just basically comes from the change of base formula. So that log is the natural log, so it's base e. So because I've changed it to base e, and we know how to differentiate base e, it then works. Again, that's just the mechanics behind it. All we really need to know is, okay, we'll do it the same as e to the function x, but I'll just also multiply by the natural log of the base. So that brings us to, I guess, the world's easiest differentiation question. Y equals e to the x, the derivative is e to the x. But we could, if you think about it, use that formula, because if I differentiate the power, differentiate x, you get 1. And so I've now multiplied it by 1, so it's e to the x. So if it was e to the 5x, differentiate the power, you get 5. So it becomes 5e to the 5x. 4x plus 3, differentiate the power, you get 4. So it becomes 4e to the 4x plus 3 for the derivative. That doesn't have to be a linear function. Mind you, I think all the questions in our exercise that we're going to do are all linear functions, but later on, probably in the year 12 work, we'll handle these other ones. But it's still the same idea. Differentiate the power, x squared plus 3x plus 2, we get 2x plus 3. Times e to the x squared plus 3x plus 2. So if I want to find the equation of the tangent to the curve y equals e to the power of 2x plus 1, and it's at the point, well, the x value is 1, and so the exact value for y would be e squared plus 1. First thing we've got to do is work out the slope, and that's what we have the derivative for, our gradient function. So if we differentiate e to the 2x plus 1, we get 2e to the 2x. Remember, that's not the slope, that's the formula that allows us to find the slope. So now we know that, okay, well, when x equals 1, that derivative would be 2e squared. So there's my slope. Point slope formula, y minus the y value, e squared plus 1, equals the slope, 2e squared, times x minus the x value 1, and expand that whole thing out. I've put it in general form. I mean, it's not a very nice, neat looking thing, but it is what it is. But there's our equation. 2e squared x minus y minus e squared plus 1 is equal to 0. That would be the equation of the tangent. All right, so let's have a look at this one where the base is not e. So we have 4 to the power of x squared. And so what I said was, well, we'll do it exactly the same. Differentiate x squared, we get 2x, but I'll also multiply it by the natural log of 4. So log 4. So what is this thing I'm calling the natural log? Well, it's the inverse function to that e to the power of x. So the exponential base e. So its inverse is the natural log. Because remember, we saw that logs and exponentials were inverse. The natural log is the inverse to the base e exponential. So if y is equal to e to the power of x, then x would equal the natural log of y. So the natural log of y is base e. So you can see we write it like that. Mind you, we don't always write it like that. Often we write it as just ln. Now I think that comes from the French, because the French are funny, and they say words the wrong way around. So they don't say natural logarithm, they go logarithm naturel. And so it's ln. I think that's where it comes from. I could be wrong. I might have just made that up. I probably did. But the other way is, if you don't see a base written down, we assume it's base e. That's where you've got to be careful, because of course on your calculator you have a log button, but log is base 10. So they actually have ln there for the natural log. But when we're doing our work, if we don't see a base, we assume they're talking about the natural logarithm. Okay, if I had to simplify then the natural log of 1 on e. Well, 1 on e is the same as e to the power of negative 1. I could bring the power to the front and I get minus log e, but log e base e would be 1. Remember we had that log law? Log a base a was always equal to 1, so the natural log of e is equal to 1. So we get negative 1. E to the power of 2 log 3. Well, again, the e and the log will cancel, but it can't cancel whilst that 2's at the front of the log. So we need to bring the 2 into the log. So we get it as e to the log of 3 squared. Now the e and the log will cancel, and I'm left with 3 squared, which is, of course, 9. So I'll stop speaking so you can start working. Here we go.